Hello, dear IGCSE students. Today we are going to go to the first part of revision for paper 6. Let me remind you that paper 6 is one of the most easy papers. Today we are going to go through the most repeated questions in the last years. So let's start. The first part here is about separation techniques. So how can I obtain pure water from a mixture? When you see this statement, how can I obtain pure water? You have to say simple distillation. If this question is more than 1 mark, what would you say? You have to explain the simple distillation process. You have to say that you are going to heat the mixture till evaporation, then cool down vapor by a condenser. Then next question, how can I obtain a pure sand from the mixture? You're going to ask yourself, is the thing you're going to obtain, is it soluble or insoluble? So in this case, sand is insoluble. So what can I do? I will go for the filtration technique. And since this question is more than 1 mark, what would you say? You're going to explain. First of all, I will filter the mixture using a filter paper. Then you have to say that the sand part will be on the residue, left behind as a residue. Then you're going to say wash with distilled water and finally dry between filter papers. Then another question here is going to ask you, why is the sand rinsed with water in stage B? Here, as we can see here in this part, he is washing the sand, which is the residue. Why do we wash the residue? To wash out any soluble salt. I need to get the maximum yield of my filtrate. That's why I'm washing. So the answer for this question, why do I rinse the residue? To wash out any soluble salt. If it's named like here, sodium chloride, you can say that to wash out any soluble sodium chloride. How can you check out the purity of the sodium chloride? How can I check the purity of any substance? By checking the melting point. By checking the melting or the boiling point. Each substance has, a pure substance has a sharp boiling and melting points. Then here in this question, as asking you also, how can you order them? But if I'm going to order them out, first of all, I do have a mixture. So this is number A, the first thing. Then I'm going to add some water, so C. Then finally, I'm going to filter this insoluble part. So A, then C, then F. What comes next? We have many options. One of them that you're going to rinse the sand with water. Then you can filter them out. Then you can evaporate. Also, we have many different answers. All are correct. A, C, F. Then we have B. We can say D. Then E also, it will be correct. Okay. Then here we do have different diagrams. And he's asking you here in this diagram, if I do have a mixture of sand and let's say a salt, what has been added to the mixture here? So what has been added here is water. Another question, what is the general name given to the liquid in the dish? What we call this, the part within the dish, we call it a filtrate. Name the separation process. Separation process here is what? Filtration. How would you know to stop heating the dish in A? How can I, so what, this is evaporation stage. This stage is called evaporation. So when would you stop the evaporation? When the solution is saturated. So when can I know that the solution is saturated? You would see crystals on the tip or the edge of the glass rod. So how would you know when to stop heating? The answer will be when crystals appear on the edge of the glass rod. Let me revise with you the lab tools. Here we call this an evaporating dish. This is called a tripod. This is called a Bunsen burner. This is called a glass rod or a stirring rod. This is called a beaker. This is called a filter funnel. And this is a dish. Then here we have another, this is called a stand, and this is called a clamp. This is a funnel, and this is a dish. So which of the reactant was excess? Here in this picture, you can see which one is excess. The one which is excess, the part which is unreacted. So in this case, the unreacted part will be the zinc oxide. Suggest why this apparatus wouldn't work. What is missing here in this apparatus? What is the mistake in this apparatus? As we can notice that what is missing here is the filter paper. So why this apparatus would not work? Because there is no filter paper. Describe how crystals of zinc chloride can be obtained from zinc chloride solution. So I'm obtaining here a soluble crystals from its solution. How can I obtain a soluble crystals? What would you do? It depends how the question, how many marks the question is out of. First of all, let me tell you, if this question out of 3 marks, what would you say? I'm going to say that you have to heat till crystallization point. Then leave to cool, then dry, filter, then dry between filter papers. Let me repeat, you're going to heat till crystallization point, then leave to cool, then you're going to filter your crystals and dry between filter papers. It's going to ask you, why don't you heat in oven? The answer would be to avoid lost water of crystallization, to avoid lost water of crystallization. Then here we have, what is the name of the, what is used to add to the strontium carbonate to the acid in stage number 1? So here, what is used to add the strontium carbonate? Strontium carbonate is a solid. So how can we add a solid to the acid? Using what? Using a spatula. So what is used? I'm going to use here a spatula. So name the dilute acid. Let's see the salt. The salt is strontium nitrate. So what do you think the salt is? The acid here will be nitric acid. If I'm preparing a sulfate salt, the salt will be sulfuric acid. If I'm preparing a chloride salt, the acid will be hydrochloric acid. So in this case, sodium nitrate. So the acid is nitric acid. Give one expected observation in stage 2. What am I adding? I'm adding carbonate to an acid. So what is an observation here in stage number 2? That when I have excess, what will happen? The fizzing will stop. So when you add a carbonate to an acid, you will observe fizzing. When you reach a stage where there's an excess, what would you observe in this part? You'll find that fizzing or effervescence stops. Why is heat not necessary in stage number 2? What is the function of heat generally in our chemistry? Is to increase the rate of the reaction. So why heat is not necessary? Why heat is not necessary in stage number 2? So the answer here will be that reaction is fast enough at room temperature. Sometimes he's going to ask you, why do I heat? So if he's asking you, why do I heat? You're going to say to speed up the reaction or speed up the dissolving process or the reaction, whatever is there. So generally, the function of heating is to speed up your process, whether it's a reaction or dissolving. And if he's asking you why not heating, you're going to say that because the reaction or the process, whatever the question is given, that is fast enough. The process is fast enough. Explain why the mixture is heated here. See, he's asking you here, why do we heat the mixture in step number 2? So why do we heat? Speed up. Here I'm dissolving. So I'm going to say here to speed up dissolving. Name the solution obtained in step number 3. What is the solution called here? The solution here, that this part, we call it a filtrate, and the sand part is called what is called a residue. What position of should the air hole of the Bunsen burner be when heating the hydrated zinc sulfate? So how would be the air hole here? How should it be? So if I'm heating something, the air hole should be open so that sorry, okay, to allow more air to go through this hole and to allow the flame to stay on. Okay, so the answer here is the hole should be open. The hole here should be open. Okay, then here, this is chromatography. Identify 2 errors in the way the student set up the apparatus. Here, as we can see, we have 2 major mistakes in the chromatography. The first mistake here is that the baseline is drawn in ink. The second problem here is that, as we can see, that the spots here are below the solvent level. So these are 2 common mistakes. One of them, the baseline is below the solvent level, and the second thing that the baseline should be drawn in ink. Okay, then here, another question of chromatography. His chromatography paper is already given. He's asking you which ink contains the greatest number of soluble dyes. You're going to just count how many spots are there. As we can see here, that the black color contains the most spots, so it is the color that contains the most soluble dyes. Which 2 inks are made of single soluble dye? So single soluble dye, it means that when after chromatography, they would end up in 1 spot. So as we can see here, that I do have the yellow and the blue. Suggest how the experiment could be changed to find out if the red ink contains different dyes. So as we can see here, the spot of the red did not move at all. So what can we do? We are going to change the solvent. So if he's telling you that the solvent I used on the first time was water, I'm going to say use organic solvent or use alcohol instead of water. If he did not mention the type of the solvent, just try to change the solvent. Why baseline is drawn in pencil? So the answer for the very common question, the answer for this is that because pencil is made, pencil is insoluble in water. Here, we have a copper oxide. Let me remind you that copper carbonate was green, copper oxide is black, copper ions or copper as a solution like copper sulfate, it is blue. So here, copper oxide, he's telling you this experiment. This is a part of a question. So in this question, he's telling you when you pass hydrogen, you're going to end up with copper. You're going to end up with copper and steam. So he's asking you here, when copper oxide turns into copper, what will be the color change like? So the answer here will be, it will turn from black to reddish brown. Then here, why U-tube is used in the ice. So what is the main function here for inserting the U-tube inside the ice? The answer will be to cool down. So steam condenses and becomes a liquid. This is a question out of 2 marks. So again, you have the first mark is that you have to cool it down. And the second mark, you have to say that the steam condenses and becomes a liquid. The third question here is that large amount of unreacted hydrogen should not be allowed to escape. So why is that? Why can't we allow hydrogen to escape in the lab? Why? Because hydrogen is flammable or explosive. Show how the unreacted hydrogen can be collected and its volume be measured. So what should I do here? He needs also a labeled apparatus. So what should I do to collect a volume of a gas? I will use a gas syringe. So you have to draw here a gas syringe. Take care that when you draw a gas syringe, you're going to draw here a syringe along with a bunch here. And don't forget that after you draw your syringe, that you have to make here calibrations. Calibrations is out of 1 mark. Okay, so when you finish, don't forget your calibrations. Okay, a syringe along with calibrations. Okay, so here we do have an experiment. In this experiment, why would carrying out the experiment in a polystyrene cup rather than a boiling tube improve the accuracy of the results? So what is the function of polystyrene cup in paper 6? It is to reduce the heat loss. Why does it reduce the heat loss? Because it's a better insulator. So in this case, question out of 2 marks, you're going to say that polystyrene cup is a better insulator to reduce the heat loss. How would the temperature change is measured after 1 minute if instead of using, let's say that I'm going to use, instead of 40 or 20 centimeters of water, I'm going to use the double. Instead of 20, I'm going to use 40, or instead of 40, I'm going to use 80. What would happen? You are going to say that I would have half change in the temperature. Why have a change of the temperature? Or I can say that water is going to take a longer time to heat up. So both answers would be correct. Half change on temperature, or water would take longer time to heat up. Then here suggest a temperature for the solution if the solution were left for 2 hours. What will happen after, if I'm going to do my experiment, then I'm going to leave my experiment for 2 hours. What will happen? You will find that the solution is going to retain the room temperature. What is the normal room temperature? We are going to use 21 or 22 degrees Celsius, which is room temperature. Why? Because heat is lost to the surroundings. So temperature would be 21 or 22. Explain your answer as heat lost to the surroundings. What type of change energy occurs when the solid D dissolves in water? I'm going to watch out my results. If the temperature is increasing, so this is an exothermic reaction. What about if the temperature is decreasing? I'm going to say that this is endothermic reaction. Students did the experiment using a copper instead of a boiling tube. Give one advantage of the change of this change to the apparatus. If I'm going to use copper instead of this boiling tube, what will happen? We know that copper is a better conductor. So what would you observe? I would observe a higher temperature change. Why? Because copper is a better conductor. So this is out of 2 marks. I'm going to figure out, notice that I do have higher temperature change as copper is a better conductor. Suggest, this is one of the most important repeated questions in paper 6. Suggest one change you could make to the experiment to obtain more accurate results. When you see this word, more accurate results, what would you say? The easiest choice you have to go for is that if I'm using a measuring cylinder in my experiment, so I'm going to say that use a pipette or a burette instead of measuring cylinder. How? Because I'm going to say that because this pipette or burette is more accurate in measuring volume than measuring cylinder. So now you got your marks. You have to mention this as a comparison. Don't say more accurate and that's it. No, you will lose 1 mark for this. Take care that you have to say that measuring the burette or pipette is more accurate than measuring cylinder in measuring volumes. Then we have here just how reliability. When you see the reliability, also you have to memorize this answer. When I say how can the reliability of the result could be checked, 1 word is the key. Remember R for R. To check the reliability, I have to repeat and compare the results, or repeat and take the average. So when you see reliability, repeat and compare results, or repeat and take the average. State 2 sources of error in the experiment, suggest 2 improvements. So what can be the sources of error in my experiment? First of all, if I'm using a measuring cylinder, you can say that this is a source of error. How can I improve? Use a pipette or a burette instead of the measuring cylinder. Another source of error. If this experiment is only carried once, I can say one source of error is that this experiment was carried only once. How can I improve this error? Repeat the experiment. If this experiment includes titration, I can say that one source of error can be passing the endpoint. How can I improve this? I can say that titrate slowly and watch carefully the end point. So all of these can be sources of error. Also in titration, I can say one of the common sources of error is parallax error. How can I avoid this error? By looking perpendicularly. All of these are sources of error. What else? If I'm having an experiment that includes heat change, so I can say that insulate, or read carefully the question. If he's not mentioned, or he's using a beaker in this question, you can say that using a beaker, how can I improve this error? I can use a polystyrene or increase the accuracy by using a polystyrene cup. I can say I can improve the accuracy of my experiment is that if he's already using a polystyrene cup, I can say insulate or use a lid or lag your tube so that I can reduce the heat loss. All of these can give you better accuracy, okay? Then here also one of the most common questions here, that advantage of using a pipette to measure the volume of hydrogen peroxide. Let me repeat that this question is out of 2 marks. So you have to say that the pipette is more accurate than measuring cylinder. Now you got your 2 marks. So just to explain what disadvantage of using a pipette to measure the volume of hydrogen peroxide. So disadvantage of a pipette, also if this question is out of 2 marks, you have to say that it is slow to run out of the pipette. So the reaction does not start at once. So not only slow, if the question out of 2 marks, you have to say that the solution would be slow to run out of the pipette. So the reaction will not start at once. And now we got your 2 marks. Explain one disadvantage of using a beaker instead of conical flask. So beaker is difficult in swirling. Conical flask is better because I can swirl it easier. Suggest what might have caused the result is to be anomalous. So if you are using, if this experiment is titration, so what would cause the anomalous result is that I did overshot the end point. How can I avoid this? You can say that, again, anomalous result by titration is that you overshot the end point. So how can I avoid this? Again, repeat the experiment and watch the change in color carefully. Give one advantage and one disadvantage of using a measuring cylinder to add acids to the flask. So one advantage and one disadvantage. One advantage of using a measuring cylinder, that measuring cylinder is quick and easy to use. What about the disadvantage? Disadvantage is that it is inaccurate measurement compared to a burette. So this advantage is that it is inaccurate compared to a burette, but a big advantage of it is that measuring cylinders are fast and quick, also easy to use. Then here we have indicators. I'm just gathered the most important indicators for paper 6, which repeats a lot. Method orange. Remember that B for banana, so for the bases, it's yellow in color, and A for apple, so the methyl orange with an acid gives a red, like an apple. Then we have the litmus paper is blue with the base, and it is red with the acid. Then we have phenolphthalein, which is pink in case of base, and it is colorless in case of an acid. And thymolphthalein is opposite to phenolphthalein. Instead of pink to colorless, it's going to change from blue in case of base into colorless in case of acid. And this came in the specimen 2020 exam. Thymolphthalein color change is from blue to colorless. Then here, this is the pH paper. Remember that the strong acid is from 1 to 3, and usually it's like red in color. Then we have the weak acids are like orange in color. The neutral is like 7, pH 7. So it is also green in color. Then we have weak alkali from 8 till 10, and we have the strong alkalis from 11 till 14. Suggest a purpose of the using starch in a solution. Whenever you see starch, so starch is used an indicator. So how can you show that a solution of benzoic acid is a weak acid? How can I, if I'm having an acid, how can I show that it's a weak acid? You can use simply a universal indicator. Is going to give you a pH from 4 to 6, okay, maximum 6 and less. Actually, because it's a weak acid, if its pH is more than 3, so from 4 to 6 is fine, okay. And also I can use instead of a universal indicator, I can use a pH paper. It's going to give you an orange color for a weak acid. So you can use a pH paper and indicate the color, or a universal indicator giving you a specific pH. Then this question also, why does the mass of the conical flask? So this is the rate of the reaction, and in this case of the reaction, you have to know that, and this is called a balance, this is called a conical flask, this is a cotton wool. Then we have lumps of magnesium carbonate here along with nitric acid. So why does the mass of conical flask and its content decreases? Why? Because carbon dioxide gas is produced, or carbon dioxide gas is given off, which escapes. So just the purpose of the cotton wool here, it has two functions. One of them is to allow the gas to escape, and the other function is that it stops the acid from being lost and from splashing. So sometimes going to ask you, split this question into two parts. Sometimes going to ask you, why don't I use a sponge instead of a cotton wool? In this case, you're going to say that to allow the gas to escape. If he's asking you here, why don't I leave the flask totally open? So this is to allow the splash and loss of the acid. If this is one question, purpose of cotton wool, you have to mention two things. It allows gas to escape. On the same time, it prevents the splash and loss of the acid. Why does the graph level off? Sometimes going to give you a graph. You're going to explain this in details in a graph video. Okay, graph levels off means that it's going to become a plateau. Okay, why does that? Because all in this case, read question carefully. What is the limiting reagent and which one is the excess? So if the acid here is the limiting reagent, you're going to say because all acid has been used up and reaction stops. So this question is out of 2 marks. Reaction stops or finishes. The second mark that you have to say that that all acid has been used up. Then another type of question here, that we have a precipitate. And here in this question, he is measuring the height of precipitate. And in this exam, you were supposed to measure the height of precipitate, this dark gray part, using your ruler in millimeters. Describe the trend in heights. As we can see, how the trend of height, it increases, then remain constant. So increases, then remain constant. Suggest a different method. Instead of the measuring of the height of precipitate, how can I compare between different amount of precipitate in different tubes? What would I do? I can say that here I'm going to filter precipitate, then dry, and then weight the solid. So instead of measuring the height, I'm going to filter, dry, and weight the solid. Then here, this is an important note. I need just to tell you that here, sometimes in the table of the graph, it will be a time like this. Take care that this small part, the inner part is in minutes and the outer part is in seconds. So here, this is 1 minute. Then this is here, how much seconds, let's count. This is 4 seconds. So I'm going to multiply the time this minutes, how much seconds in 1 minute? 60 seconds, because this is 1 minute, and here this is 4 seconds, so 60 plus 4, this is 64, and so on. So if I'm having the short arm, let's say on 5, and the big arm on 15, so I'm going to multiply 5 multiplied by 60. This is going to give you, I think, 120, then plus 15, this is 135, so 135 seconds, and so on. You have to multiply the minutes by 60, then add the seconds. Sometimes when it's a measuring cylinder or thermometer, sometimes the readings are from up to down, and sometimes it's from down to up. So take care when you read carefully. Always follow the scale. So the scale here is from 4 to 5. I'm going to count this way. This is 4 and 1, so this is 41. Another thing here, the scale here, it's the opposite. So it's from down to up. So I'm going to count here. This is 20, this is 21. And take care when you write the numbers. All the numbers should go for the same decimal place. If this is 21 points, let's say 0.5, and I'm going to write 21 should be like this, 21, and here 0. Okay, if this is 4.1, okay, if this is 4.1, but take care when you write this reading. This is 38, this is 39, okay, 38, so this is 38.1, 0.2, 0.3, so this is 38.3. If I'm going to write 39, I'm going to write 39 like this, okay? If I hope you got it, all should be to the same decimal place. If I'm going to write one decimal, for the number which has no decimal, you have to write 0.0 beside it. Okay, so here I do have a diagram. This is gas collection. So as we can see here, sometimes I'm going to tell you a gas, and this gas is more dense or less dense. How can I collect the gas which is more dense? So here, let's, in this question, is telling you that I do have here a chlorine gas, and chlorine gas is more dense than air. So how can I collect? What is the mistake in this diagram? So the mistake here is that upward delivery is not a suitable method. So upward delivery here is not a suitable method. So you have to, the gas jar should not be inverted. So what is the mistake here? That the gas jar should not be inverted, as chlorine is more dense than air. Another thing, that I don't have here a bunch. A bunch here is missing. So you can see here there's a bunch on the first flask, and there is no bunch in this here on the second flask. So this is the second mistake there. There is no bunch in the second flask. Why the gas produced in flask 1 is passed through concentrated sulfuric acid. So what is the function of the gas in the sulfuric, what is the function of passing a gas through sulfuric acid? To dry the gas. Let me remind you that the only gas that cannot be dried using sulfuric acid is ammonia. Why? Because ammonia will react with sulfuric acid, forming ammonium sulfate. So ammonia as a gas can be dried using calcium oxide or calcium carbonate, but not at all. It cannot be used, or not be dried using sulfuric acid. Okay. Sometimes a mistake is that when you dry, sometimes this tube will not be drawn here. There will be no tube here. So what will be the mistake? That the delivery tube is not inserted inside the sulfuric acid. So this can be also a mistake, but in this case, the drawing is totally correct. Here, the drawing is totally correct. So I'm not going to do a comment here. Only two mistakes is that gas jar should not be inverted, and here's that there is no bunch. Let me tell you that a major difference between a gas jar and a measuring cylinder, the only difference between them, that the measuring cylinder has calibrations. Measuring cylinder has calibrations over it, while gas jar is not calibrated. Here, why is oxygen collected above water? Why do we collect oxygen above water? Because oxygen is slightly soluble in water. Any gas, why is it collected above water? Because it is soluble, it's insoluble or slightly soluble in water. Another repeated question also is going to ask you, why do I use fume cupper for any experiment? So when you see fume cupper, because you are going to say, because I do have here a toxic gas. So you're going to watch if you have a certain gas in the experiment, like a chlorine gas, you're going to say because chlorine gas is a toxic gas, or there is a toxic gas. Then here we have this famous experiment of the thiosulfate, where we have a precipitate which is being formed. First of all, sometimes going to ask you, why do we have here a printed words on the sheet? Or sometimes going to ask you, why do I use a white tile? So in this case, in titration especially, why? To watch carefully any color change. So here in this question, why do I have a printed words? so that to watch carefully when the precipitate forms. Okay, so just the effect of the result. Instead of using the same experiment, I'm going to repeat. Instead of using a large flask, I'm going to use a small flask. Okay, instead of 250 centimeter flask, I'm going to use a smaller flask. So instead of a big flask, I'm going to use a smaller flask in a precipitation. This is only in precipitation experiments. What would happen? So what would happen is that you would notice that the crust disappear faster. Why is that? Because I do have smaller volume, so the depth will increase. So more depth. So why again? What will happen when you repeat again? This is only in precipitation questions, because sometimes in titration questions is going to ask you the same. What will happen if I'm going to change the volume of the flask? The answer is no effect, because same volume of solution is there. No precipitate is formed. Okay, so here, if you have a precipitate and it's going to change the size of the flask, here you're going to say that the crust will disappear faster. Why is that? Because the depth increases using a smaller flask. Then here, titration. Titration is one of the most important topics. We're going to explain in details again in graph video. Let me tell you that sometimes I'm going to have two solutions in a burette. Let's say that I do have here solution A and I do have a solution B. Here I do have a flask and I do have another flask, and this contains the same thing. Let's say in this titration that I used 10 centimeter cubic of solution A, and in this B I used 20 centimeter cubic of solution B. So which solution is more concentrated? So if I am testing what's inside the burette, so if I'm testing what's inside the burette, it means that the one which did the job with a very small amount is the one which is more concentrated. So here, if I'm going to compare what is in the burette, so the one which will do the job with a small amount is the more concentrated. So in this case, I'm going to say that A is more concentrated than B. Why is this? Because C, small volume, neutralized the same amount. What if I'm having the same experiment, but here I do have two flasks. I have here a flask A and I do have here a flask B that contain two different solutions. And here I do have the same thing in the burette. Here, I'm going to repeat the same. Here, I need 10 centimeter cubic to neutralize, but here I did use 20 centimeter cubic instead of 10. So which one is more concentrated, A or B? For this example, B will be more concentrated. Why? Because it required more volume to be neutralized. So again, let me repeat. If I'm testing what is in the burette, so the burette which did the job with a smaller amount is the one which is more concentrated. But if I'm testing what's inside the flask, so the one which required more amount of the thing which is in the burette is the more concentrated. Why? Because it required more volume to be neutralized. This is very important, and it's a very common question in many exams. Why is the conical flask rinsed? So why do I rinse? This is also a repeated question. To remove impurities, or to remove solution from the previous experiment. Why doesn't it matter? If a little distilled water is left in the flask after what has been rinsed, let me repeat here. How can we fill the flask? We fill first of all, I'm going to get a measuring cylinder. I'm going to measure, let's say, 25 centimeter cubic of my, let's say, base, and I'm going to put it here. So if small droplets of water is left in the flask, this will not be a big deal. Why is that? Because it does not change the amount of the solution. It does not change the amount of the solution as it was already measured using a measuring cylinder. What about the burette? The burette, no, I directly put my solution in the burette without measuring. So that would be a very big error if I did use or did rinse my burette with distilled water, then I used it in my acid. I should first rinse the burette with distilled water, then I should rinse it with whatever I'm going to fill with. So I'm going to rinse again with, let's say, if I'm going to fill this with an acid, so I'm going to rinse again with the acid. So there's 2 steps in washing the burette, because I do depend on my burette in my measuring. I don't use something else before I add my solution in the burette. So why was the burette is then rinsed with an acid? Why? To avoid dilution of the acid. If I used here distilled water and I just added my acid will completely fill the burette and a water will be part of my burette. So this will cause dilution of the acid. So again, why is the conical flask rinsed? To avoid or to remove any impurities or solution from the previous experiment. Why? Don't it matter if I'm going to leave some droplets of water in my flask? So because it does not change the amount of the solution where volume was already measured using a measuring cylinder. Why burette is rinsed with an acid? To avoid dilution of the acid. State the effective any on the volume of dilute hydrochloric acid used in experiment 1 if the solution of sodium hydroxide is warmed before adding of the hydrochloric acid. What is the effect of warming? It speeds up the reaction. Does it change the amount of the acid I'm going to add? No, definitely no. So the answer here is that would have no effect, as temperature do not change the amount of sodium hydroxide. Titration, change the temperature, would do no effect. Here I have this question. Explain the advantage of using the type of conical flask instead of type used in investigation. So in this experiment, I'm using a sponge, and in this sponge, if I am going to remove the sponge, I'm going to remove the sponge, this will take a lot of time. To set up the experiment, it would take a lot of time. So it's easier for me to use this divisor or use a tube. In this tube, I'm going to put a thread and I'm going to use a small test tube or boiling tube. I'm going to put the other reactant in the test tube. So using a divisor or using a test tube, small test tube with one of the reactants inside, it would be very important so that it can adjust the starting of the experiment. So what is the advantage of using this type of conical flask, the one which contain divisor? I can say that I don't have to remove the sponge to help to ensure gas don't escape. Okay, I can say that the reaction can be started by tilting or shaking the flask. Why sponge must be replaced immediately after sodium carbonate is added to the boiling tube? Why should I fast add the sponge? So that what? To prevent any gas from escaping. Always the sponge is to prevent gas from escaping. Explain how the apparatus could be altered so that the sponge does not have to be removed. So this came in another exam. How can I do some changes so that I don't have to remove the sponge? So what can I do for this? Again, use this type of flask. So I can use here a divided flask, and I can tip the flask to start the reaction, or I can say put one of the reagents inside a boiling tube and shake to start the reactions. So this is to avoid removing the sponge. Okay, and what is the problem if I remove the sponge? Gas would escape. So describe a test for carbon dioxide. What is the test? This is called a mortar. This is called a pestle. Mortar and pestle are used for crushing, and this is called a dropper or a pipette. What is a test for carbon dioxide? Lime water is going to turn into milky. Explain why lumps of copper carbonate were crushed before adding the dilute. And why do I crush? To increase the surface area so that reaction becomes faster, okay, or increase the rate of the reaction. Suggest how a sample of copper could be obtained from a solution of copper nitrate. So how can I obtain a sample of copper from a solution of copper nitrate? I do have copper nitrate. And I need to obtain this copper. How can I do this? I will add a more reactive metal, let's say zinc or magnesium. So add zinc or magnesium, the more reactive metal will displace copper in copper nitrate, giving you copper solid. So the answer here is that use a more active metal. You must name it. Magnesium or zinc would work. Okay, displacement reaction would occur. Then we have here a crucible. This is called a crucible. This is called a balance. Okay, this is called a watch glass, and the rest is labeled. So here, describe how the student could find out all the water of crystallization has been removed from the zinc sulfate. How can I know that all water has been removed? What should I do using this apparatus? I will heat and wait till I obtain constant mass. At this stage, you would know that all the water has been removed. Let me tell you that a test for water, chemical test for water, can be used using anhydrous copper sulfate turning from white to blue, and also anhydrous cobalt chloride turning from blue to pink. Okay. So here, how can I make sure that all water has been? So again, you have to heat and wait till you have constant mass. This is fractional distillation. Sometimes going to ask you here, what is the mistake? Make sure that here we have a bunch. Make sure that the bulb of the thermometer is near the opening of the condenser. This is called condenser. Water in from down, water out from up. Sometimes going to ask you why is water in from down and water out is from up. Why is that? To provide efficient cooling, as it will take more time to cool down. So he's asking you here what this is called a fractionating column, and it contains small beads. So this is fractionating columns, and this is called a tripod. So one mistake in the apparatus, as we can see here in fractional distillation, no heat should be applied below the beaker, only heat should be applied here. Which liquid is going to collect first? Again, he's going to read the question well, the one which has the lower boiling point. I'm going to tell you that. Let's say that ethanol is going to boiling point is like 96 degrees Celsius, and I do have, let's say, water boils at 100 degrees Celsius. So which one will be collected first? The one which has a boiling point. So I'm going to say here ethanol. Why? Because it has a lower boiling point. Why would it be better to use an electric heater instead of Bunsen burner to heat water in ethanol? Why? Because ethanol here is flammable. Sometimes going to ask you, instead of using a Bunsen burner, what is a better method? You're going to say electric heater or use a water bath. Why? Because ethanol is flammable. This is electrolysis. Electrolysis also important in paper 6. Draw an arrow on the diagram to show where should heat must be applied. So what do I heat in electrolysis? I do heat my electrolyte. So this is silver chloride. I'm going to heat it till it becomes molten. Remember that electrolysis is done for either a solution or for a molten state. So in this case, I'm going to apply heat here. Observations here. Observation, like any electrolysis, I do have silver and I have chloride. Silver will turn into silver atom, and the observation here is going to say that I have a gray silver deposit, and other observation that chloride will turn into a green gas. So another observation is that I do have green gas bubbles. So just one reason why zinc is not suitable you'll be using as an electrode, because zinc is highly reactive, okay? Because zinc is not inert, it is reactive. So one additional safety precaution that should be taken when doing this experiment, give reason for your answer. So whenever you have an experiment and this experiment releases a gas, especially chlorine gas, so a precaution for this is using a fume coupled. Why? Because chlorine gas is toxic. You can say also a well-ventilated lab. Why? Because chlorine gas is toxic. Suggest a suitable material from which electrodes are made. So another electrodes is if he is asking you for a metal, so I'm going to go for platinum. If he did not specify a material, whether it's a metal or a non-metal, I can say graphite. Chlorine gas was bubbled into aqueous solution of a sodium salt. Color of the solution changed from colorless to orange. Identify the sodium salt and explain what happened that causes color change. So in this case, I do have sodium bromide. So we know that as we go down, the reactivity of group 7 decreases, right? So chlorine is more reactive. So when you pass chlorine over a sodium salt, you notice that I do have an orange color. So what was here the substance? It was a bromide. It was here sodium bromide. So here, when you do this, you have here a bromine gas. Okay, so the color of the solutions changes from colorless to orange. It means that the salt here was sodium bromide. Why does that happen? Explain your answer. Because chlorine is more reactive than bromine, and displaces bromine to form bromine gas. As flame test, very important. You have to know how can I do a flame test. Flame test, you have to know that use a nichrome wire dipped dipped in concentrated, and you have to say concentrated, HCl. Sorry for this. Okay. Concentrated HCl. Okay. So nichrome wire dipped in concentrated HCl. Then what should I do? I am going to dip the wire in the salt and place in the blue region, or the hot part, or the roaring part of that roaring. Roaring means very hot part. Okay, roaring part of that flame. Okay, then the last thing is that observe the changes in the flame color. Okay, this is how can I use, or how can I do the flame test? Use a nichrome wire dipped in concentrated HCl, then dip the wire in a salt and put in the hot or blue or roaring part of a flame. Then finally observe the color change of the flame. Solid should be heated gently. This part also, let me go through this part. This part is very important. Sometimes I'm going to ask you, why do I heat gently? You have to read the question well. Are you having a solid or are you having a liquid? So this part, if I am having an aqueous sodium hydroxide and aluminum foil, this is test for nitrates. Remember this? This is test for nitrates. Why do I gently warm this? Why do I gently warm this? I do have here a liquid. So warming gently here is that sodium hydroxide is hazardous. So avoid spitting out of the mixture or of the sodium hydroxide. Because sodium hydroxide is hazardous, to avoid the spitting out of the mixture. Now, what if I do have a solid? What should you say? You can say also that the solid can spit out of the tube, or because the tube might crack. So if I'm having two test tubes, again, why heat gently? If it contains liquid, I'm going to say because this liquid is hazardous, or to avoid the spitting out of the liquid. If I'm having a solid here, I can say because the tube might crack, or I can say to avoid spitting out of the solid. Here, this is cracking. So what is the purpose of the mineral wool? Mineral wool here is to absorb here the paraffin oil. In this case, you have to read the question here. In this case, I do have a paraffin oil. So I'm going to say the purpose of the mineral wool is to absorb the paraffin oil. Give a test to show the presence of alkenes. How can we test for alkenes? Any unsaturated hydrocarbon. How can I test for it? Bromine water. The color change is from orange into colorless. Why must the delivery tube be removed? When you finish it, you have to remove the delivery tube fast before heating is stopped. Why should I do this? To prevent the back suction of water that might crack the tube. First gas jar is not used. So the first sample is not used. Why is this? Because it contains impure. So the sample collected is not pure. So you can say that it is not a pure sample. It contains displaced air. So why don't I use the first sample? Because it is not pure. It contains displaced air. This is the last question here. This came in 2013. So yeah, let me tell you that the potassium manganate color is purple. I can use also potassium manganate, KMnO4, acidified potassium manganate. I can also use it as an indicator. Here in this question, he was having a purette and he filled it with potassium manganate. And in the conical flask, he had two salt solution. Remember that potassium manganate is very strong oxidizing agent. So what color change would you observe? You are going to change to notice that whenever you start dropping the conical, the potassium manganate, this purple color will change once it drops in. It's going to be colorless. So the colorless, the color in the conical flask is colorless. What would it change? On the end point, the colorless, one drop of the potassium manganate is going to turn it into purple. So the color change during titration using potassium manganate is from colorless into purple. Why? I don't need indicator in this case, because we know that potassium manganate is already pink in color. One excess drop, the color of the solution will turn into pink, indicating the end point. So why don't I need an indicator when using a potassium manganate in titration? Because again, potassium manganate is pink in color. So one excess drop color is going to change into pink, indicating the end point. And that's it. Hope you go through these questions. Again, if you have any concerns, any comments, please leave it down in the comments under the video. Good luck for your exams and stay tuned for the graph video. Good luck all.